Yes, the zombies are back now and they're ready to test. They'll take that development code and tear it from your chest. Refactor your mind, take the test and retrograde. All with an undead beat.
You're watching Rails testing for zombies, and this is level 6, using factories. Now, all throughout this course, we've been focused mostly on fixtures when we're trying to load data for testing. This level is all about another alternative to fixtures, which is called factories. So what is it that's so terrible about fixtures? Well, I mean, if you've been around the Rails community long enough, you've probably heard that fixtures are bad. So let's look at maybe some of the things that aren't so good about them, although to this point we do see that they do their job well. So one of the problems is that associations are hard. Greg showed this to you in some of the earlier levels, where to create a zombie that had tweets, we had to reference that zombie as its zombie ID from the tweet fixture back to the zombie. You could see that that could get to be really difficult when you start to get a lot of fixtures or a lot of test cases. You'll quickly learn that your fixtures file exponentially grow with edge cases because you might want a zombie with a name or a zombie with a certain name or a zombie with a certain graveyard, and so it multiplies out. And finally, you'll find that they really do repeat a lot. It's a lot of, this is my zombie, this is his name, this is his graveyard. This is my zombie, this is his name, this is his graveyard. And factories really try to kind of appease all of these issues. So in this level, we're going to talk about Factory Girl, which is another external gem. This one's written by Thoughtbot that you can use to implement the factory pattern. So what Factory Girl does is it allows you to define valid model attributes. It allows you to easily modify them at runtime or at test time. And it allows you to inherit and modify attributes and configurations between your factories. So how do we install it? Well, just like everything else, we go to the gem file. In this case, you're going to notice that I'm actually grouping the Factory Girl gem into development and test groups, not just test alone. And you'll also notice that instead of using the Factory Girl gem, which is kind of the generic, I'm using Factory Girl Rails. So what this does is it allows Rails to add hooks to automatically generate our factory files for us when we do things like run the Rails generator for a model. So let's see what running that model generator might look like. So here, we'll say Rails generate model zombie. On the command line, we'll go ahead and say that a zombie has a name and a graveyard, both of which are strings. And if you look closely in the generator, you'll see that it actually invokes Factory Girl. And it will create a new file for you at test factories zombies. It's the pluralized form of the model name that you gave it. What does that zombies factory file look like? Well, by default, it's going to look something like this. It's going to say factorygirl.define. So Factory Girl, name of the gem, .define, and that block that it takes is basically saying inside of here I want to define some factories. And inside of this we actually have a DSL written by Thoughtbot that is purely about these factories. So here it's going to say I have a factory called zombie. It's going to default to the model name that we used earlier. And it's going to say, oh, since we defined some attributes of the command line, it's going to go ahead and put those in for us just like it did with fixtures earlier. So you're going to see name, my string, graveyard, my string, again because we defined them as strings earlier. And let's just quickly look back at how this might relate to the earlier fixture file that was automatically generated by Rails before. I should also note here that because we're using the hooks for Factory Girl, it's actually not going to generate the fixtures for us anymore, but rather generate the factories instead. So let's look at the two files. So on the left-hand side, you see we've got test fixtures zombies.yaml, and that's the YAML file. In this case, we've got ash, name ash, graveyard, Oak Park. And to the right of that, you see our factory definition file, which is located in test factories zombies. So it's in factories rather than fixtures. It's a Ruby file rather than a YAML file, and it's pluralized just like the fixture was before. So here you've got Factory Girl define do, factory zombie, so we're creating a factory called zombie. And here I've dictated that the name is ash and the graveyard is Oak Park. And then how do we actually use this in our tests? So whereas before we would say zombies in all lowercase and pluralized and pass it an attribute that matched the name that we defined earlier, so in this case ash, when we use a factory, we can just say factory zombie. We want to say basically factory, give us a new zombie, right? So it looks like that. Let's look a little bit at this factory method that we used here. So it's a little bit weird because, it's a method that is capitalized as if it were a class name or a module, but it's taking a parameter, which, is the factory that we want to instantiate. That actually equates to factorygirl.create with the same factory name. So it's just kind of a shortcut to make writing our test a little bit easier if what we want to do is create. And I say if what we want to do is create because factorygirl actually gives us a few different options of what we might want to do with our factories. So the first one that we've discussed is factorygirl.create. And what that's going to do is going to create, instantiate a new zombie, give it the attributes that we've defined, save it to the database, and then give us back that saved zombie. So what that boils down to is factorygirl, take this action and perform it on this factory. The other actions that we can take are factorygirl.build, where it will create a new zombie, load it with attributes but not save it, and also not validate it. Or you could do factorygirl.attributes for this particular factory. And rather than returning a zombie instance, it's simply going to return you a hash of attributes that make up a valid zombie. Let's look back at fixtures real quick just to compare again some of the differences as these things start to grow. So over here you see a fixture file with zombies in it. In this case I've got 3 zombies. I've got Ash in Oak Park, Bill in Oak Park, and Mike in Sunnyvale. Right? How could we do this as a factory? Well, in our factory file, we would do factorygirl define, factory zombie, so it's a generic zombie factory. I'm going to say that my generic zombie is always called Ash, and I'm going to say that my generic zombie is always in Oak Park. I could then define an inherited factory underneath that. In this case, I'll call it Zombie Bill, just so it has a different name, and I'm going to override the name to be Bill. So what it's going to do is it's going to take the parent one, which is zombie, it's going to load those attributes, and it's going to override with anything that I've specifically defined. So in this case, name will get overridden as Bill, but I'm going to take in Graveyard Oak Park from the parent. And in the case of Mike, where both values are different, I can still define it as a child of the original zombie factory, but I'm just going to override both values in this case. So let's look a little bit at how to actually interact with the factory. Let's say, for example, that we have a zombie class where we do some validation, which Greg actually talked about earlier. So we're validating the presence of name, and we're validating the presence of graveyard in this case. So let's say we're writing a test. And in that test, we're going to say, we want a couple of zombies, for example. Maybe we want to test to make sure one zombie doesn't equal another zombie. So we might say, zombie1 equals factory zombie. So that's going to use the default zombie factory. It's going to create us a zombie named Ash in Oak Park, and it's going to store that onto zombie1. Maybe in that same test we say, we need our second zombie. So I'm going to say zombie2 equals factory, give me another zombie. Well, the factory is going to say, okay, well, name is Ash, graveyard is Oak Park. If you look closely up to the validations at the top, you see we also have a uniqueness constraint. So in this case, when we call the factory, it's going to instantiate a zombie with a name of Ash and a graveyard of Oak Park, but this time when it goes to save it to the database before returning it to us, it's going to throw an exception and explode. In this case, we get an active record, record invalid, because we've got the uniqueness constraint on name. We already created a zombie with a name of Ash. Validations fail. So how do we make this work? Let's say you have a test that you do need both of those to load. How do you get around the validations? Well, if you remember earlier, we actually defined 2 or 3 factories where we had different names. That would get around the validation. So one option here is to rewrite zombie2 equals factory zombie as zombie2 equals factory zombie bill. What that's going to do is use the other factory with a different name. That's basically going to sidestep the validation and everything will work. The downside there is that we're now no longer better than fixtures, because if we have to define a new factory every time we need a variation, it's basically fixtures again. So how else could we solve this problem? Well, factorygirl actually allows you to override attributes at runtime, as I mentioned at the beginning. So we could say zombie2 equals factory zombie name colon ash1. We happen to know that the first one was named Ash, so in our test we can just say I need a new one after that one and I'm going to call it ash1. That'll do it, and that's great. But there's actually an even better way to go, which factorygirl gives us, called sequences. Sequences allow us to generate unique information based on the number of times that information was called. So over here in this definition, you can see factorygirl define do, factory zombie do, and now I have a sequence name. So I'm calling the sequence method and the attribute that I want the sequence to run on and be applied to, and I'm passing it a block. The block takes one argument, which is a numeric, and that block represents the number of times that sequence has been called. So if I call the zombie factory 1 time, that'll be a number 1. If I call it 5 times, it'll be a number 5, 10 times 10. So in this case, I'm just taking that numeric and applying it directly to the string. So I'm guaranteed a unique name, ash1, ash2, ash3. So getting back to the example that started this, we might have the test that says zombie1 equals factory zombie. Great, we get our zombie ash back. And now we could say zombie2 equals factory zombie. And you'll notice that the two names are different and both of them are saved and no exceptions were thrown. That means that we could do something like this. We could say, in this test, we need 1,000 zombies. So we'll say 1,000 times, give me a zombie, which will create a new saved zombie each one of those times. So you're going to see zombie1, ash1, zombie2, ash2, zombie3, ash3, 4, 5, 6, up to 1,000. And that means we now have a zombie factory. So now that we've seen how to make a zombie with a factory, let's look at a case where we need to make an association. So in this case, we're going to introduce a weapon model and say a weapon must always belong to a zombie, right? So we have a belongs to zombie and a validates presence of zombie. So in theory, a weapon can't exist without a zombie. How would you define that factory? Well, you might do something like this. So in our test factories weapon.rb, we would define a new weapon factory. Let's say this weapon is a broadsword, right? We're going to say association zombie. And what that's going to do is that factory girl is actually going to look at our weapon class. It's going to see that we have an association named zombie. So it's going to say, okay, I know where to apply this zombie to. Factory girl is also going to look into itself and say there is a zombie already defined as a factory that I can use. So in your weapon factory, you say association zombie. It knows what the local method is in the weapon, and it knows what the factory is to create that zombie. So now, whenever we just say weapon equals factory weapon, we not only get a weapon, but we also get a zombie that it belongs to, right? The idea behind factories is that they're always valid when you call them. So now let's look at another case, still with associations, but this time let's look at it from the zombie's perspective. So you can see we've got class zombie has one weapon, right? So we've restricted zombies to only having one weapon, but we haven't required them to have a weapon. So a zombie may or may not have one, they're valid without one, and that's perfectly fine. So how might you dictate a factory where, let's say, we need for a particular test a zombie with a weapon? So what we might do is open our definition, and we might make a high-level factory called armed zombie in this case, right? Because in theory, we might have already defined a zombie factory. So here, we've got our armed zombie, sequence name, we get the unique name, association weapon, which we just learned about before. So whenever we create a zombie, it will automatically have a weapon, and it's got a graveyard of Oak Park. That's great, except that if you actually try to use this, it's going to explode. And it's going to explode because Factory Girl doesn't know anything about an armed zombie. Because this factory is defined at the top level, there is no parent to this factory, it's just going to take the name and try to turn it into a constant. So it's going to say, okay, you want a factory called armed zombie? I'm going to assume you have an armed zombie class. That's not going to work in this case. So how do we get around that? Well, factories actually take parameters. They're optional. In this case, we could say class zombie. And so what that's going to say is Factory Girl is going to say, you need an armed zombie. I know how to make an armed zombie, and I know what class represents an armed zombie, and everything will be great. Or, better yet, since we had already defined a zombie factory, we could just define an armed zombie as a subfactory to the original one, and it will just inherit the inferred name from the parent. And even better, we might say, well, for this particular factory, we don't just want the generic weapon, which if you remember back was a broadsword. Maybe for this particular factory, all of these zombies have hatchets. And so we can say association, weapon, factory hatchet. So how do factories actually look in tests? We've seen how they operate, we've seen how to define them, let's see how to actually use them. So here's a test that we might have written earlier at the unit level. So in this case, we are loading a zombie from the fixtures, we are decapitating the zombie, and we are asserting that his status is now dead again. It's fine, it's a perfectly good test. There's a couple of issues here though, in that one, we're still using fixtures, but two, we don't know what the status was necessarily before we called decapitate. So this test could be passing because maybe the fixture actually defined his status as dead again, decapitate didn't actually do anything, and here we are, right? A passing test that didn't actually test anything. So Maybe to get around that, you had a particular fixture called not dead again zombie, right? Maybe the status was dead in the fixture. So in this case, you're kind of saying, I know that it wasn't dead again to start with. I'm asserting that after decapitate, it's dead again. That's a better test. But you can see we now have new fixtures. So using factories, we might actually just say zombie equals factorygirl.build zombie. In this case, I use build instead of create because I don't actually care if it's saved. But we're running into the original issue of we don't explicitly know what the status was before decapitate was called. So we might get around that by just doing a runtime setting and saying status is dead when I create you, I'm going to decapitate you, I'm going to make sure you're dead again after. So now that we've seen what it looks like at a unit level, let's take a look at an integration test. So here's something that we kind of saw a little bit of earlier. So we're going to test that navigation is available to the zombie page. We are going to load a zombie from the fixtures. We're going to load a tweet for that zombie from the fixtures. We're going to visit the root URL. Again, we're using Capybara here. And we're going to say within a particular area of the page, we want to make sure there is a link to the zombie and that when I click on that link, I end up on the zombie's page. So using factories, we could say zombie equals factory zombie. We could say tweet equals factory tweet. In this case, you can see I actually passed the zombie into the tweet, and that's because the tweet factory, in all likelihood, has an association to a zombie already. And if I just said factory tweet, it's actually going to create a new tweet with a new zombie that isn't the same one that I just created. So in this case, I pass in the zombie that I've already created, so it overrides that auto creation. And now I have a zombie, a tweet, and everything else stays the same. Even better than that, I could actually just say tweet equals factory tweet, knowing that it would create a tweet and a zombie for that tweet. And then I could just say zombie equals tweet.zombie, right? Only call the factory once. I happen to know that it will automatically create the association for me. Everything else stays the same. Congratulations! You've made it to the end of all of the videos for this course. And you now know how to make a zombie factory. And we're actually going to test you on that right now. But please stay tuned because at the end of your challenges, we're going to have a wrap-up video to tell you where you can go to learn more.